The task here is to determine if two binary trees are leaf similar, meaning their sequences of leaf values must be identical. The sequence of values from the leaves of a binary tree is determined by traversing the leaves from left to right. The function required for this task accepts two binary trees, root1 and root2, and returns true if and only if the sequences of their leaf values match. To solve this, we start by declaring two vectors, leaves1 and leaves2, which will store the leaf values of the two trees respectively. The collectLeaves function is called on root1 to gather its leaf values into leaves1. Similarly, the collectLeaves function is invoked on root2 to populate leaves2. Finally, we compare the two leaf vectors with the expression return leaves1 equals leaves2, returning true if they are identical and false otherwise. The collectLeaves function is designed to traverse the binary tree and collect the leaf values. Since it is a void function, it doesn't return any value, but instead modifies the leaves vector passed to it. If the node is null pointer, the function terminates early because this indicates that the tree is empty or we have reached the end of a branch. If the current node is a leaf, meaning it has no left or right children, its value is added to the leaves vector. This step is crucial for gathering the leaf values from the binary tree. If the current node has a left child, the function recursively calls collectLeaves on the left subtree. This ensures that the function continues to explore the tree down the left side until all leaves are reached, adding each leaf value encountered to the leaves vector. Similarly, if the current node has a right child, the function calls collectLeaves on the right subtree. This means the function will continue down the right side of the tree until all leaves are found, adding these values to the leaves vector. Here's a simple example to illustrate. Consider two binary trees. Tree 1 has leaf nodes with values 4, 5, and 6, and tree 2 also has leaf nodes with values 4, 5, and 6. When collectLeaves is called on both trees, it gathers these leaf values into leaves1 and leaves2. Since both vectors contain 4, 5, and 6, the function will return true, indicating the trees are leaf similar. In conclusion, the collectLeaves function works by recursively traversing the tree, identifying leaves, and adding their values to the leaves vector. The check for whether a node is a leaf is done using the condition. If this condition is met, the node's value is added to the leaves vector. After collecting the leaves for both trees, the two vectors are compared to determine if the trees are leaf similar. This method is both efficient and straightforward, ensuring that each node is visited only once, resulting in an O of n time complexity, where n is the total number of nodes in each tree. Let's give this algorithm a test to ensure it functions properly. Experimenting with different tree configurations will help verify its reliability and versatility.